Let's look at the graduation test. First, we are going to look at the test for smoothness. Test for smoothness is only matters for the graphical methods. If the graduation process results in rates that are smooth but shows little adherence to the data, we can say that the rates are over-graduated. It is smooth but less or little adherence to data. For example, if I were to draw a graph here, this age and this is the hazard, so I will have a very smooth line, but the actual data is scattered somewhere far from the line. This is over-graduated situations. So you have to fix this. Make sure that it is actually close to the data. The second situation is if it is sufficient smoothing and insufficient smoothing, and then we call it under graduation. For insufficient smoothing, you are going to get something like this. I will redraw again better. Okay, this is insufficient smoothing. If you compare to the actual data is really close to the line. So you can see that the pattern, the line is not smooth at all. So further smoothing technique is needed. That's why it is important whenever that you draw the graph, you have to make sure that it is smooth and also fit to the data. This is what we want, something like this. This is the smooth. The data is just close or nearby. The second test is goodness of fit test. For goodness of fit test, usually we are going to use the chi-square test. In this test, for the mathematical formula method, we are going to reduce the degree of freedom for each of the fitted parameters. Degree of freedom for each of the fitted parameters. Under the second method, which is the standard table. For the standard table, we are going to reduce the degree of freedoms as well for each of the parameters, but we have to reduce further for some constraints that is imposed to the standard table. The third one would be the graphical method. Under this method, the rule of thumb says to reduce 2 to 3 degrees of freedom for every 10 ages groups being fitted. This is to check whether it is fit, the model fit to the actual data or not, whether it deviates from the actual data or not. The third test is the cumulative deviation test. Under the cumulative deviation test, we want to see that the deviations of the actual from the deviations of the estimates from the actual data is not far from each other, and the summations of the error are usually equals to 0. This one is also sometimes we call it as error test, where we have the summations of all of the errors usually equals to 0. So it means that if you, I'll just illustrate graphically here. This is age, this is T hazard. So for examples, you have, this is the smooth line or the lines of the graduations, which is the models that you are going to use, and here you have some data here, some data here, some data here, some data here. Okay, for each of the data, this one here deviate from the actual data. Here the line is deviating from the actual data here, but when we add up all of the errors, that means the actual minus the estimates, and sum all of that, we are going to get it 0. So that means that the line is in the middle of all of the actual data, so it is the best fitted for all of the actual data. Okay, that's it for the graduation chapter. Thank you.